Okay, let's look at math packet number 7. This first one says you throw 3 darts at the board, shown below. If each dart hits the board, how many different possible point totals can you score? So here's the key thing. How many different possible point totals can you score? I had some people say, well, if I throw my 3 darts and they all hit in to the bullseye, that's 10, 10, and 10, so that's 30 points. Then if they all go into the 4, that's 12 points. And if they all go into the 1, that's 3 points. There we go. Are those the only possible combinations we can have?
No, it could be like 10, 1, 4.
Yeah, we're going to be throwing those 3 darts. We can hit them into lots of different, let me just go down so we have more room to work. We can have lots of different combinations. So the easiest way to solve this one is to actually write out all the different point combinations. There are 3 darts, and there are 3 different point values. We're going to end up with our total. Some of our combinations are going to be the same point values. There's 27 outcomes that we can get. So if I throw the first dart, it can land in 3 different places. The second dart can land in 3 different places. The third dart can land in 3 different places. There are 27 outcomes if I write them all out. But we don't want duplicates. We only want different possible point totals. We don't want all of the outcomes because there's going to be different ways that we can make it. So if we had a 10, a 4, and a 1, first dart, second dart, third dart, and then first dart, second dart, third dart, it's the same total. We only want to count it one time. So if you list out each of your outcomes, you're going to cross off the totals that are the same. I listed out all 27 outcomes. I did, okay, if I hit the bullseye with my first dart, what else could I hit? Then if I hit the bullseye, or if I hit a 4 with my first dart, what else can I hit? So there's going to be 27 outcomes, and you need to cross off any duplicate totals. So every time you get your 30 the first time, if you see a 30 again, cross it off.
So that doesn't count.
Right. You're only going to count the first time you see that point total. So there's a whole lot that I crossed off because a lot of the point totals duplicate. Because we flip it. I hit it with the second dart. Oh, nope, this time I'm hitting it with the third dart.
Counting with the ones that you crossed off, is it 27?
Yes.
Okay.
So there's 27 total outcomes that we can get. 3 times 3 times 3. So if you write them all out and you add them all up, you can see your answer is going to be just a number, one number. How many different point total outcomes are there?
27.
Nope, there are 27 outcomes altogether. You have to cross off the ones that are the same. So your answer is going to be one number.
10?
We're not answering it right now. You figure it out, okay? But we know how to do that one now, right? Let's look at our second page. Oof, there's a lot of us doing this one. that we're missing some key things in our sentence or in our problem. Your neighbor Henry is cleaning up his yard for the season and has already collected 7 bags. So we've got that 7 bags sitting right there. You notice that his trees have not yet lost all of their leaves, and when you ask him about it, he says that he expects that as they fall, he will be able to collect another bag of leaves every 3 days. How many total bags of leaves will Henry have collected after 57 days? So 3 bags, or sorry, every 3 days he collects a bag. And we're going for 57 days. How do I find X? How many bags is he going to get? Zoe?
19.
How am I going to find it? Yeah, I want to get X by itself. X is my bags. It's 3 days. Every 3 days. So I'm going to divide by 3. But what X equals when I divide 57 by 3, is that my answer? Why not, Zoe? Yeah. What else does he already have?
He has 7.
He already has 7 bags. Can't forget about the 7 bags that he starts with. So he has 7 bags, and then he's collecting every 3 days. Okay, so figure out how many bags he's going to have every 3 days for 57 days, and then don't forget about the 7 bags that he began with. Does that make sense, Zoe? Yeah. Yeah. Five-card challenge. We know the 5-card challenge. We love the 5-card challenge. So make sure your total equals 3. Make sure we are in math 6, so we need to come up with 12 points. So what is one way that we could come up with an answer of 3? What equation did you have, Nolan?
Well, 10 minus 7.
10 minus 7. So again, remember how we do this. 10 minus 7 equals 3. So we used 2 cards. So we get 2 points for that. We need to make it all the way up to 12 points. Keep your teacher's life easy and put them in a row. When we put them all over the page, it's hard for me to keep track of what you're doing. So keep them nice and organized. You can only use each of these cards one time in an equation. Okay, but when you're making your new equation, you can use those cards again. They always need to equal a 3. Who could tell me another equation? Zoe.
10 plus 8 minus 10 minus 5.
You said 10 plus 8 minus what?
10. Well, using 10 2 times.
Oh, that's using 10 2 times. You can only use the 10 one time because there's only one 10 card there. Tristan W.
10 plus 5 in parentheses minus 8 minus 4.
10 plus 5 minus
8 minus 4.
You're saying that equals 3. Let's check. 10 plus 8 is 10 plus 5 is 15. Minus 8 minus 4. So 15 minus 8 is 7. Minus 4, it equals 3. So this would be 1, 2, 3, 4 points. So right there, we're halfway. That's 6 points. We're halfway there. All right. Next page. Find the area of the shaded region. All work must be shown. So this is a multi-step problem. Your first step is to find the area of the full figure. So that full figure is this rectangle. How do we find the area of a rectangle? Area equals what, Will W? Length times width. So if we do length times width, we have 12 times 10. So the area of my figure, 12 times 10 meters squared. But now I need to find the area of the shaded region. How do I find that? That's not a regular shape. How can I find that area? What do I have to find first? What do you think, Nolan?
Like the size of it. Like that's a 2 and that's a 7.
So that's going to tell me, if I do the 2 and the 7, that's going to tell me the area of my white space. So the white space equals 7 times 2, 14 meters squared. Is it important to know that?
Yes.
Why is it important to know the white area? What can I do with my information now? Tristan?
You can take the area of the whole shape and subtract it by the area of the white space.
If I have my full rectangle figure, I subtract out the white space. I take out this white space, taking that out, I'm left with just my shaded. So this is a multi-step problem. You find the full figure, you find the area of what we need to take out, so you subtract it out, and then you're left with just the shaded space. So for those of us that had turned it in, is it making a little more sense now? Okay. Our next page. Complete the table for the total blocks in each figure. So this is one block. We don't need to know that it's yellow or if it's red because it's a block. How many blocks are in figure number 1, Nolan? 1. Oh, so this is figure 1, this is figure 2, figure 3, figure 4.
Wait, we only do total blocks? I was doing yellow and red.
Complete the table for total blocks in each figure. You're giving yourself more work to do, sir.
Well, at least I did it.
Yeah, you're learning. How many blocks are in figure 2? Aiden? There are 9 blocks in figure 2. How many blocks are in figure 3? Because you're still counting that yellow one. Remember, that yellow one is still there. It's not an empty hole. It's a block. So how many blocks are in figure 3? Zoe? 25.
Oh, I completed it. Same here.
How, you can complete the whole thing, that's fine. I'm just gonna be looking at the total column. How many blocks are in figure 4, Peyton?
There's 49 blocks.
49. Now, we need to figure out how many are gonna be in figure 5, so we need to find the pattern. What pattern did you find, Nolan?
So like it adds 2 blocks. Like wait. What 2? I know the answer is. Can I just say what my answer is? The total blocks is 81. Right?
What?
That's
Oh,
Let's see how Nolan got that.
I just kind of knew it.
These numbers are my favorite kind of numbers. Anybody, not prime, I do like primes, but I like these even more. These are perfect squares. 1 squared, 1 times 1 is 1. What is the square root of 9? 3 squared is 9. What's the square root of 25? Oh, five. What's the square root of 49? What's the square root of 81?
I told you they had 2. And look at 1, 3, 5, 7, 9. 2.
And then you have to square it. So you add 2 and then square it.
So I was right.
You were right, and I'm showing you why you were right. I'm showing you what that pattern is. So how many blocks are going to be in figure 6? 3 up.
No. Wait.
How did you get 103? Did you follow the pattern? 11 times 11 is not 103. Landed? So you have a calculator right next to you.
I actually don't know.
Oh.
One, 0, 121.
Landon, what did you get? Did you do it yet?
Do I need to do 11?
You could do 11 squared or you could do 11 times 11. On the calculator, it means the same thing.
122.
You're going to finish the table for those last two. Continue going with the pattern.
Yeah.
Oh, our big formula page. Okay. A lot of us have gotten the formula. If you did not get the formula, this is important that you write it down. The formula for the volume of a sphere is 4/3 times pi times r cubed.
I have a question.
Yes.
What is pi then?
Oh, who can tell Nolan? Bria? 3.14 is pi. If you do it on your calculator, it goes on and on and on and on, but we round it to the 100th place. So we can say easily 3.14 is pi. On your calculator, there's a little pi button. So you can just multiply it. You can just type that and multiply it. If you don't have the pi key on your calculator, you're going to want to get a calculator that has it. We've shown which calculator we should be getting for next year.
Is it this one? No, it's like the end.
So,
Mine's more like advanced.
the second one says show your calculation. So we're going to put the numbers in. So this is important. We are putting our numbers in. So we are going to do 4/3 times 3.14 times, what is R? What is R? Kira? 9. Our radius is 9. And we need to cube it. What does that mean? Anthony?
5 times 3 times.
So if we're going to cube 9, it's 9 times 9 times 9. Does it really help to have a calculator?
Yes.
Yes, it does. What did this thing come up with? Your answer, you're going to put right here.
This is my
Zoe? No.
Yeah, my calculator's going crazy. I don't even know what to do.
Then we have math 6. The formula for the surface area of a sphere is 4 pi r squared. So 4 times pi times r squared, 9 squared. You need to do the math, and you're going to put that answer down here. 4 times 3.14 times 9 squared. What is 9 squared? What's 9 times 9? Zoe, 81. Nolan, I have a bucket of simple calculators in the back seat. You can go borrow one. You forgot to divide it by 3. You had the 4 times pi times r cubed, but don't forget to divide it by 3. Yes, well. Okay. Anthony. I'm sorry, what? It's the formula. The math gave it to me. So it's math. There are formulas for finding volume, and you just use it. I cannot tell you off the top of my head why it's 4/3. Sometimes I can easily, when it comes to spheres and circles, I can't explain it easily. When it comes to like pyramids with triangles, a lot of times you multiply by 3 or divide by 3 in the formulas because of the 3 sides. The spheres, it gets a little more complicated. It's not an easy explanation. Yes. Or this? Yes. Yes.
So I don't have fractions.
So you multiply by 4, and then the end you divide it by 3.
Oh.
So if you can't do the fraction on your calculator, it's okay. You multiply it all by 4, and then you divide it by 3. Yes. Yeah. So instead of doing 9 cubed, if you found what 9 times 9 times 9 is, you would put that in. So what you could put into your calculator is 4 times 3.14 times 9 times 9 times 9 divided by 3.
So would it just be 4 times 4 times the egg number?
Yeah. You can see that.
Then you would divide it by 3.
Yep.
The answer is 27468. No, 27468.
That's to find the surfaces. Or you asked me about that? Yeah. No. Oh my goodness, it is a beautiful circle. Okay, friends, we are not done. Shh. Please sit down. Yes. Turn it into the middle tray. Shh. Mean, median, and mode. You were to have been filling this in and then finding your mean, median, and modes. Shh. So you know how to find the mean, median, and mode. And then our last page. Create a graph that represents the data shown in the table. What is the easiest type of graph we could do to show our data? A bar graph. You could do it on the back side of your paper. You could do it on the bottom of your paper in that empty square. Okay, you need a bar graph. So you need to represent. Remember, when we are making a graph, you need to label. So down here, you would want to label bag of chips, candy bar, and we want to put, what are all these things? These things are our snacks. Okay, so we're going to put the snacks on the bottom. You should put your title for the snacks. Going up the left would be preferences or people. How many people prefer the bag of chips? How many people prefer the candy bar? So we're gonna wanna put our numbers going up the side. 0, 1, 2, and so on. Okay, so make your bar graph for the snack preferences. Make sure you put your labels on it. For Math 6, that's all we have to do is just creating your table, making sure you put your labels. I'm going to stop with the recording now. If you get home tonight and you forget what to do with one of the pages, you can refer back to the recording. I will put it on the YouTube channel. Remember, we must turn these in tomorrow.